we are now going to graph tangent functions. So we've graphed sine functions, we graphed cosine function, and now we're going to talk about tangent functions. So again, when we go to graph trigonometric functions, we look at that table of values that we should have memorized for different values of angle radians or angle measurements. So if we look at this guy, let's look at just one period of this. Okay, so let's look at one period. So we're going to look from here to here. Okay, that's where we're going to look. And where we get these points from. Okay, where do we get these asymptotes from as well. So if we look at the value of tangent when we are at 0 radians or 0 degrees, we are at 0. Okay, so that's this point here. So if I kind of look, I like tables. So at 0 radians, okay, we are at 0. If we look at when we are at pi fourths radians or 45 degrees, you'll notice that the tangent is 1. So at pi fourths, we're at 1. The same thing as when we're at negative pi fourths, we're at negative 1. Okay, so at negative pi fourths, we're at negative 1. So that's this point right here. All right? Then let's look at pi halves. Okay, at pi halves and negative pi halves, we are undefined. Tangent is undefined at those points. So what we end up with is an asymptote. We get closer and closer to having a graph for pi halves, but we don't get there. Okay, because at pi 6, let's see, at pi 6, actually, I guess we're not worried too much about pi 6, because that is not closer to pi halves and pi 4, sorry, it's actually closer to 0. But we get closer, so we asymptote, okay, we asymptote to pi halves and negative pi halves. So let's talk about some of the characteristics of y equals tan x. All right, let's talk about some of this character. First of all, it's periodic, just like sine and cosine, so it repeats itself over and over again. All right, so that's one thing to keep in mind. One is the domain. Okay, so we think of the domain is all real numbers except at pi halves or multiples of pi halves. So pi halves, 3 pi halves, 4 pi halves, which is just, no, not 3 pi halves, sorry, pi halves, 3 pi halves, 5 pi halves, negative pi halves, negative 3 pi halves. So it's all real numbers except multiples of pi halves. I might put like odd multiples of pi halves. So like 3 pi halves, 5 pi halves, 7 pi halves, so it's got to be odd multiples of pi halves. At these values, the graph has a vertical asymptote. I spelled asymptote wrong up here. Tink. All right. The range is all real numbers. Okay, so it doesn't have an amplitude. Okay, the range is all, should say all there too, real numbers. All right, the graph will not have an amplitude. Attitude? amplitude. Okay, so what do I mean by that? So sine and cosine, when you think about them, they had waves. Okay, they had waves. All right, where they had a height and a top and a bottom. Okay, they had a top and a bottom. Tangent doesn't have a top and bottom. It can equal anything. All right, so it doesn't have a top and bottom. It goes on forever. It can go way up high and way down low. In fact, as my radians gets closer and closer to pi halves, my tangent starts getting really, 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 really big. Okay. All right. The graph has a period of pi. Okay, so every pi tangent repeats. Has a period tangent. Has a period of pi. And the reason why is, if you think about the graph, okay, so we think about the quadrants. In quadrant 1, tangent is positive. In quadrant 2, tangent is negative. When we go back down to 3 and 4, it's positive and negative again. So it's like positive, negative, positive, negative, positive, negative. So it just keeps repeating that way. All right? And the x-intercepts right, where the x where y is 0, graph occur at x equals 0. So when we're at 0 radians, plus or minus pi radians, plus or minus 2 pi radians, plus or minus 3 pi radians, and so on. Okay. Okay, so that's where we have the x-intercepts. So now let's talk about when we stretch our graph a little bit. We'll talk about shifts in the next lesson, when we stretch our graph and shrink our graph. So if we have y equals a tan x bx, so what is, if there's a number in front of tangent, what does that do to the graph? If there's a number from the x, what does that do? All right, so so we talk about the halfway point. So if we talk about the value of y at the halfway point, so the halfway point before was pi fourths, and the value was 1. All right, so if you think about the graph, so I don't have any place for a here. Okay, we'll write it down. Just write in the space below. So a is the value of y at the halfway point. All right, so if we think about asymptote, we're at 0, 0, this point right here, and this point right here. So what is the value of y there? Okay, before, when it was at pi fourths, we talked about being pi fourths, it was at 1, because the tangent of pi fourths is at 1. So we're talking about this point right there. All right, the period is pi divided by b. So we can shrink or expand how long the period is. And the vertical asymptotes are at pi over 2, the absolute value of b. Okay. I guess maybe this one should be absolute value as well. All right, so let's do this. Let's graph some. All right. We're going to do 3 examples. Let's do 2 on this slide. All right, so example 1, we're going to do y equals tangent, I'm sorry, of 4x. I'm in a singing kind of mood. And then for number 2, we're going to do y equals 3 tangent 1/4 x. And we're going to graph, let's get in the habit of graphing 3 periods. So 3 of our little swishies. I think tangent graphs are really cute. I kind of like them. Anyways, it doesn't matter. Okay. So we're going to find the value of A, which is the y-coordinate at the halfway point. We're going to find the period and the vertical asymptotes, and then we're just going to kind of make our graph fit that. All right. So let's see. Y-coordinate at halfway point is A. All right, and in this case, A is 1 because there's no number here. Like in number 2, A would be 3. Okay. My period is going to be pi divided by B, which is pi over 4. And then my vertical asymptote is at pi over 2b, which equals pi 2 times 4, which is pi 8. All right, so let's graph 3 periods of this. Okay, so here is my coordinate plane. All right, my period is going to be pi force long, and I know I'm going to have asymptotes at pi 8. All right, so my period is the distance between asymptotes, if that makes sense. So I know here I'm going to be at negative pi 8, there's going to be an asymptote, and at pi 8, there's going to be an asymptote. So I'm going to draw in those asymptotes. Okay. That's one period. We want to go on a period on either end. So we're going to add pi force to that. Notice the distance between here and here is pi force. That's how long the period is. So I'm going to go another pi force. So 1/8 or 1/8 plus 1/4 is 1/8 plus 2h, which is 3/8. All right, so that's where I'm going to have another asymptote. Going to try to make it the right distance. Oops, I'm going to make that black. All right, so 3 pi 8ths, and then negative 3 pi 8ths. There's going to be some more asymptotes. Bing, bing, whoops. Bing, 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 bing. Bing, 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 bing. Okay. All right. So now we need to get our swishies in. So the middle swish, all right, my middle swish, I know this is going to be 0, 0. All right, that's going to be at 0, 0. Halfway point, all right, so the halfway point would be here and here. All right, I know I'm going to be at 1, so 1, negative 1. So I'm going to put a dot here, a dot here, and then I'm going to draw my swish. All right, so, and I mean, I could write pi 16ths there if you want, but it gets kind of wild with all the things. But halfway between 0 and pi 8 is pi 16ths, but I'm not too worried about that. I need to, though, I would like you to have this point and this point. This is always going to match the period, pi force, negative pi force, because if my period is pi force long, when I travel from one dot to another dot, I would have traveled pi force. So from asymptote to asymptote it's pi force, but every dot to every dot is also pi force. All right, I'm going to do a halfway point here and here, halfway point here and here. And again, if I wrote all those for those halfway points, it'd be lots and lots of numbers. So we're not too worried about it. Up to 1, down to -1, up to 1, down to -1, and draw my swish. And draw my swish. All right. So there's that graph. All right, so now let's do the same thing for 3 tangent 1/4 x. All right. I'm going to draw a line in between these guys. Okay. All right, so we're going to find y coordinate at halfway is going to be equal to a, which is 3. My period is going to be pi divided by 1/4, which equals 4 times pi. And my vertical I spelled asymptote wrong there too. Asymptote is going to be at pi times 2 times 1/4. All right, so that's going to equal pi over 1/2, because that'd be 2/4, which would be 2 pi. Oh, good. That's what I had in my notes as well. That's what I double check. Sometimes I do these problems, and I look at my notes, I'm like, oh, that's wrong. I'm going to record this whole slide all over again. That's pretty cool. All right, so let's graph this again. All right. This time my swishies are going to be at 3 and -3. And actually, I don't like where those are. Whoa. I don't know what just happened there. Okay. All right. So now we're going to figure our asymptotes are at multiples. Let's see, at 2 pi. All right. So let's see. We're going to be at 2 pi, -2 pi. All right. If I add another period to that, and my period is how long? 4 pi, then I'm going to go to 6 pi and -6 pi. And those are where my asymptotes are. So this was 2 pi plus the period of 4 pi. If you want to know where I got that. All right. My x-intercepts are going to be at, this will be at 4 pi. This will be at 4 pi. Okay, those will be x-intercepts. So I'm going to have x-intercept at 0. And then 4 pi, oops, and -4 pi. And then halfway points. Let's put those in. Halfway. At those, I'm going to be at 3 and -3. So let's see. 3, -3. 3, -3. 3, -3. And I'm going to draw my swishes. Alright, that last one's not very good, but what are they going to do? Fire me? Alright, so that's y equals 3 1/4 3 1/4 x. 3 tangent 1/4 x. And I was going to put an example on this slide, but I don't think we need more examples. I think we're good. So, are we good? Nope, I changed my mind. We're going to do an example here. It won't hurt. Or maybe it will. Well, I hope you don't get hurt. So, 3y equals 1/2 tangent 4 pi x. All right, so y coordinate at halfway will be 1/2. My period is going to be pi over 4 pi, which is going to be 1/4. And then my vertical asymptotes is going to be at pi over 2 times 4 pi, which is going to be pi's cancel, 1/8. All right, So let's draw. Whoa, I was trying to like scroll up and instead of draw. All right, let's draw this guy. All right, so we're gonna go to a half. We're gonna go negative a half. Our period's a fourth. Our vertical asymptotes are at an eighth. So 1/8, and then there's another asymptote. Let's see, this is gonna be at 1/4. That's where my x-intercept's gonna be. All right, so asymptote here. We're gonna have an asymptote here. So we're gonna do 1/8 plus 1/4, which is 2/8, which is 3π8. No, 3/8. So this is 3/8. All right, so let's do that in the negative space. So 1/8 x-intercept at 1/4, because that's what our period is, and then negative 3/8. Boom, boom. All right, asymptote, asymptote, dot, dot for x-intercepts, halfway, 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 and my swishy swish. She does. All right. There we go. I'm glad I did the example. All right, so that's tangents. Go, practice, ask questions.